Remember a few weeks ago we talked about the CIE 1931 color space chromaticity diagram, the idea that if you map the standard visual light spectrum, the standard light spectrum that a human being can see, then you can start to decide what a system can reproduce within that. And so, for example, we would do like a triangle or something saying, and this is what this monitor can reproduce. And in one case, we looked at old iPhone displays as compared to an sRGB display, what they could show. Well, we also have printer space. So while this is quite off, we should have more of a standard rotation, don't you think? Let me just clear this out. So if we had some monitor that produced some amount of color, right? The colors that could be reproduced by a standard CMYK printer is generally much, much smaller. Let me make another triangle, like quite a bit smaller. So this is a problem, right? Because the color gamut that we have on our display that we worked with, that we painted, can be quite a bit bigger than what we're actually going to reproduce. So we have to figure out how to shrink all of that down, what the appropriate way of minifying it is, or compressing it. There we go, what the appropriate way of compressing it is. Now, let me show you exactly what this looks like, and then we can start dealing with how we can control the different ways of handling it. So here's our snail of science. He's back. I've gone ahead and made him a bit more vibrant to make sure he's outside of the range of the CMYK. So here we have our snail. If we were to just go to image mode and switch him over from RGB to CMYK, and if I were to come over to channels, you can see that we are in fact in red, green, and blue. If I just did a quick switch to CMYK, I'd get some alerts. You are about to convert CMYK using US web-coded swap version 2 profile. This may not be what you intend. To choose a different profile, use edit convert to profile. That's how we're going to be doing it. That's how we'll change and control and oversee how we're compressing our color gamut. But for now, we're just going to display it. So I've just done a straight up web swap. Here it was originally. Here's what it will reproduce. Now, there's more to it than that. As you all know, you have to calibrate your monitor in order to see what's really going on. You have to make sure that your monitor has the appropriate profile in it. You have to make sure that Photoshop's using the same profile so that it communicates to the monitor correctly. Now we're introducing something else. It said that we were just using web swap. And notice, though, it did make it cyan, magenta, yellow, and black. It succeeded, but it just picked one and did it. I'm going to go back to RGB with an undo, and I'm going to, instead of going to image mode CMYK, I'm going to follow its advice and do an edit convert to profile. Edit convert to profile. Now we have our sRGB, which was the one I said we're going to be using, and it is by no means the best. I'd recommend, as a minimum, usually using Adobe 1998, but it's what I said to use because I can ensure that pretty much everyone can encompass sRGB. So we'll all be seeing the same thing if our monitors are calibrated. We have working CMYK US web-coded swap version 2. What a strange thing to have. We have custom CMYK as well. We have a whole bunch of different things. We have all kinds of stuff. We have snaps and swaps and all of these. What are snaps and swaps and all of that? Well, remember how we had the ICE? Well, when it comes to print, we have the same sort of groups coming together to manage it. Swap, specifications for web offset publication. Ta-da, thank you, Wikipedia. Specification for web offset publications, abbreviated SWAP, is an organization in the name of specifications that it produces. And now we know what this is talking about, so let's take a look at it. Here is a SWAP profile. And you can see how it's encompassing as according to an Adobe RGB 9098. Now notice that the sRGB is a closer match to the swap, but there are certain colors, especially the greens, and we'll remember when we switched our snail over here, it became duller, especially in the trees. It's because it was trying to push this down. Now, you can read up about how it works and all this good stuff. Essentially, it's a group talking about the standards and what you do to create those standards, or rather follow those standards. So if you've done everything with the swap profile and something claims to be able to reproduce with it, and you get two different companies that made it, theoretically they look the same because they're meeting the standards. Now, SNAP is the specifications for newsprint advertising production. So it's a different set altogether. Now, that sort of thing, that's great. We're going to go ahead and use it for just a moment, because the profile you may want to use may come with your printer. You may need to go get that. So we'll just use the working CMYK US web coded, the swap version 2. That will be fine for our needs. But now we have something a little more interesting going on. We have something called an engine, and we have something called an intent. And we have dither and black point compensation. All this is in the conversion options. So let's say we're moving towards this standard swap. Or if you have a printer profile that came with your printer, you may want to move towards that instead. I'm wondering if I've got any installed on here. It doesn't really look it, but you can get those. How do you do the conversion? Well, you can use, in my case, I've got two options, the Microsoft ICM or the Adobe Ace engine. And what they're converting to, or how is this, but how they're converting it is the intent. We'll talk about that in just a second. So what is the Ace process, the Adobe process here? So my understanding is that the Adobe Color Engine, the Ace engine, will convert RGB to lab and then lab to CMYK. And that's just lightness, alpha, and beta. And those are absolutes. It's just solid mathematics. So either RGB or CMYK can be converted to lab losslessly, which means that you can push it into that, then you push it into the next color space. That's my understanding of how it works. I honestly do not know how the Microsoft ICM engine works. I tend to stick with the Adobe Ace since I'm in an Adobe product. Yeah, that's about it. If you're interested, let me know. I'll happily research the Microsoft ICM and get back to you on that. But for now, we're just going to stick with the Adobe engine. What's more interesting is the intent. We have perceptual, saturation, relative colorimetric, and absolute colorimetric. What does that mean? What's black point compression? What's going on there? Oh, we also have advanced, which is pretty cool. So in advanced, we can do even more destination space editing if you really, really, really want to get into the nitty gritty, start getting some custom CMYKs and things going on. Hold on though, let's go back to our little drawings here and talk about compressing this down from one gamut to another. In fact, let's go ahead and talk about that in another video so you can get to that pretty easily. All right, I'll see you in the next video where we talk about gamut compression.